Hi guys. So I just finished grading everybody who's turned in the Classwork 4.4 Life Cycle of a Star packet. Some of you guys might be working on it today. Today is Friday, the 31st of April. So if you're still kind of working on it, that's okay. Turn it in. I'll grade it probably either today or early next week. Um, but I noticed one particular question that students were struggling with, and that is, what is the formula for nuclear fusion? Now, I noticed a lot of you guys probably typed into Google or found something on Wikipedia, and I got some answers like D and T yields or arrow some energy and some helium, or I noticed some other things like B and Z and MP squared and all that other stuff. Um, the formula is actually right at the top of that assignment, okay? And it is really kind of simple when you think back to your basic chemistry. So if you think back to that structure of an atom, right? You have the nucleus, which has those positive protons, okay? And then you have neutrons in the center, and then there are typically electrons on the outside, right? And the number of protons in the nucleus determines which element you are. So I only have one proton here. I have one positive charge, so therefore this is the element hydrogen. Okay? And that is key when it comes to nuclear fusion. Hydrogen is what fuels most stars. Most stars are burning with hydrogen. Sometimes they burn heavier elements if they run out of the hydrogen. But the vast majority of stars are burning hydrogen, and every single star has to start with hydrogen. No star is going to usually begin burning anything heavier than hydrogen. And when I talk about a heavier element, what I mean is that there are more protons in the nucleus. For instance, okay, hydrogen has one proton, so it's very light. Okay, a heavier element, still pretty light, but a heavier element would be something like, give it 2 electrons this time, okay, helium. Helium has 2 protons in the nucleus. I'm not worrying about neutrons right now for all my chemistry people. But hydrogen's got 1 proton, helium's got 2 protons. Okay? And in the formula for nuclear fusion, what's happening is that these protons are moving in the star so fast, they're so energized, just like you heat anything up. Like if you heat up an ice cube, you're heating up those water particles so they get faster and it becomes a liquid. In a star, it's going so incredibly fast that you're moving this hydrogen around, and eventually what happens is, if you can get enough of these hydrogen protons, okay? So here we have all these hydrogen protons, all right? So I'll put a little H above those. These are all my hydrogen protons. If enough of those hit each other, okay, when these combine, you get this gigantic release of energy, okay? This giant release of energy. As what happens is, nearly half of this explodes. So you might say, like, this one becomes completely energy, and this hydrogen becomes complete energy. It's transformed. It's no longer a physical particle, but rather it's been turned into electromagnetic radiation. Things like light and heat and radio waves and microwaves and gamma rays and UV radiation. Okay, you've heard about those things. That's all type of electromagnetic radiation. So all of that fuses. Okay, so what you get on the other side, you typically write as helium. So you're fusing that hydrogen into helium and energy. So in other words, the formula for nuclear fusion, the answer to that question, okay, I'll put in this box here, is 4H yields helium and energy, meaning that we had 4 hydrogen atoms combined together, and through the process we get a larger nucleus. So now we have these 2 nuclei stuck together into a singular helium atom. And on this side, the other 2 hydrogen, the reason that we don't see them over here anymore, the reason we don't have 4 protons total is because they were released as energy. So I'm going to kind of do a little squiggly H as our energy. The hydrogen has now become energy, so it's gone away. Now, this type of energy is electromagnetic radiation. And I've already mentioned how that comes in different forms. We're going to do a full lesson on the different types of electromagnetic radiation because this ties in with physics. This is our chemistry connection, right? Remember, the focus of Earth and space science right now is to see where does all of what we do in space or Earth sciences connect to the other sciences. So this is chemistry, right? You're talking about nuclei and atoms and chemical reactions, nuclear reactions, and the energy piece, that's really going to tie into physics when we start talking about wavelengths and frequencies and things like that. Some of that might start ringing a bell. So if you have any questions on this, if you're a little confused on that, make sure you're coming to see me during office hours this coming Tuesday, May 5th. All right, I'll be there between 11 a.m. and 1 p.m. I might make some updates to separate Earth and space science and chemistry because I don't want a whole bunch of chemistry people waiting on Earth science stuff, and I don't want a whole bunch of Earth science people waiting on chemistry stuff. So I'll post this to Google Classroom. I hope to see you guys May 5th during office hours, and stay happy, stay healthy, help each other, and help yourselves when you need to. See you guys later.